Okay, we look at rate of change. Now the term rate means what? Means that there's going to be time involved. Rate of change. So usually we are familiar with things like dy dx, and we are familiar with product rule and quotient rule and chain rule. But for rate of change, we are not dealing with dy dx. We are actually more concerned about time. So for example, I have a function that is expressed in terms of time, 3t squared minus 7t plus 1. This is a function. I want to know what is the rate of change of this function. So this could be a curve, quadratic curve, and then I find dy by dt, and then I get my the first derivative. So this is 6t minus 7. Perfect. But usually a question doesn't present itself in this way. So sometimes the question is in terms of x, a function of x. So we want to find dy by dt. We need to find dy by dx times dx by dt. Does this look familiar?
Yeah.
This is actually an example of chain rule. So this is exactly what we're going to do. We're going to look for the rate of change of a function y, that's in terms of x. And then for this to be true, x must also contain the function t. That means x must also have a influence by function t, by time t. If x is independent of t, then dx dt is 0. So x being a function of t will have a first derivative of x in terms of t. So we look at this example. Water is poured at a constant rate. Constant, this is constant value, 18 pi. Now when we look at the symbol pi, sometimes we are given the idea that pi is a variable. No, it's not a variable. Notice the unit. So what does this unit tell you? cm cubed per second.
Time.
First, it gives you an indication that time is involved, and then there is this thing. Yes, volume. So we have dv
over dt.